Okay, amazing AP Bio 2 kids. Here we are again, and we are going to partake in the lecture today that is focusing on lipids. We are on our third biomolecule group. Okay, so a little bit about lipids. First of all, you're going to see three elements present in most lipids. The reason I say most is because there's an exception to one of the groups. But the three elements that you're going to see in a lipid are carbon, hydrogen, and oxygen. And unlike carbohydrates, there is no 1 to 2 to 1 ratio between the carbons, hydrogens, and oxygens. In fact, there is a much greater ratio, than 1 to 2 to 1. You're going to see quite a high disparity between the number of hydrogens compared to the number of oxygens, because these tend to be long hydrocarbons. Okay, if you remember that term from the beginning of chemistry, a hydrocarbon is one that contains a lot of hydrogens and carbons and therefore tends to be nonpolar, giving it the hydrophobic ability, which means it does not like water. It tends to separate out, which I'm sure you've seen if you've ever seen oil and water, like in Italian salad dressing. Okay, this is a very diverse group. We focused on this word in class. The word diverse means unlike the others. For example, when we talked about carbohydrates, we had a monomer versus polymer relationship. We could talk about how the monomer, glucose, fructose, and galactose, those three monomers could be added together to make different disaccharides, and then we took the glucoses and talked about how they could bond to make our polysaccharides. Okay, unlike that group, I'm going to cross it out, lipids are very diverse. In fact, if you look down here at the examples, there are 4 different groups of lipids. Okay, we've got fats and oils, which you've probably heard the term triglyceride. Okay, triglyceride is what fats and oils are referred to. We've got phospholipids, steroids, and waxes. Those are the 4 main group of lipids, and like I said, they are not true polymers. They have a different arrangement, but we can say that lipids contain carbon, hydrogen, and oxygen in a much greater ratio than a 1 to 2 to 1, which is what we saw in the carbohydrates. Okay? So that's kind of our intro. I'm going into the first group. We're going to focus a little bit on these fats and oils. Fats and oils are basically categorized according to whether they are going to be liquids or solids at room temperature. Typically, a fat is a solid at room temperature, whereas an oil is a liquid. Okay, some common ones that you're probably aware of for the oil would be vegetable oil, canola oil, peanut oil, olive oil, whereas a fat might be lard, which is what they used to cook a lot of foods in years ago before they realized the implications of cardiovascular disease with too many of those bad lardy-looking fats. But what we can say about fats and oils, we have a couple bullets here. The first thing is they're composed of a glycerol. Okay, so let's visit that first. The glycerol is right here in the gray. Okay, my pen is always acting up. Okay, that's an O and an L, glycerol. So the glycerol is this part that you see in the grayish area. Okay, a glycerol is nothing more than a 3-carbon alcohol. Notice it ends in OL, which is because of that hydroxyl functional group. There are 3 hydroxyl functional groups that you see on a glycerol. So it's 3 carbons, hydrogens around the outside, and then 3 hydroxyl groups. Okay, down here you can see it involved in another example, but once again, here is my glycerol. So fats and oils have that piece, and then they're going to have 1, 2, or 3 fatty acids attached to them. Okay, now if it's called a triglyceride, like this word down here, that's where the tri refers to 3. There are 3 fatty acid tails, such as this bottom example. This is a triglyceride because this long chain right here is a fatty acid tail. Here's a second fatty acid tail. Okay, so 1, 2, 3 fatty acid tails, and if you examine those, a fatty acid tail is a long hydrocarbon chain. Okay, hydrocarbon chain because it's got carbon as my backbone with all hydrogens around the outside. Okay, so that's known as a fatty acid tail. So a triglyceride has 3 of those. The one that is up here is not a triglyceride. It just has 1 fatty acid tail. But you can see that the process right here is, once again, dehydration synthesis. Okay, visiting that same concept, dehydration synthesis. So we lose that water in order to make the covalent bond between those. Now the word that represents that covalent bond in a lipid is called an ester. E-S-T-E-R, ester linkage. Okay, let me write that so you can see it. E-S-T-E-R. It's an ester linkage. So it's kind of like what we talked about with a carbohydrate, how there was a glycosidic linkage between two monosaccharides. The name is still, it's a different name for a different group, but it still means dehydration synthesis forming a covalent bond in one of our biomolecule groups. So it's kind of like an analogy where you could say glycosidic linkage is to two monosaccharides as ester linkage is to a glycerol and a fatty acid tail, which is part of this fats and oils group. Okay, looking down in this section, just kind of touching base on the fatty acid. It is a long hydrocarbon tail, but I want you to notice that there is a functional group right here that we talked about before. It's the C double bonded to the O, and there is an OH. The reason you don't see the OH here is because we've already partaken through dehydration synthesis. But go back up here to the beginning part. Let me get my eraser. If I erase this, you can see there's the OH, which is on this carboxyl group right here. Okay, that's a carboxyl. So C double bonded to O, and also an OH group attached. That's my carboxyl. Okay, carboxyl, also known as a carboxylic acid. That's where we get the name acid in the fatty acid. Okay, so if you look at fatty acid and break that name apart, the acid refers to carboxylic acid, which is the carboxyl group. The fatty part refers to this big hydrocarbon chain on that. So that's where the name fatty acid comes from. Okay, so in this picture, dehydration synthesis has already taken place here, here, and here. So now I have 3 ester linkages between my glycerol and my 3 fatty acid tails. Okay, does that make sense? Okay, so now we're going to go a little bit further and talk about the difference between a saturated and an unsaturated fat. I'm sure you've heard a little bit about this. Hopefully you're educated on a little bit of nutritional information. But the saturated versus the unsaturated fat, just to show you the chemistry behind that, if it is saturated, okay, the word saturated, if you think of fully saturated with water, you can't possibly fit one more water molecule in that. But if it's saturated in terms of fat, it's completely filled with hydrogens. So we say it's saturated with hydrogens. Okay, so if you look at this first fatty acid tail right here where my pen is, this one would be considered saturated because it's a carbon to carbon to carbon to carbon to carbon to carbon with all these H's around the outside. Now I know it says H2, but if I show you, I'm going to go back a slide. Okay, if I go back one, this picture shows you a better representation of where my mouse is. This is completely saturated around the outside. What we say is every covalent position is filled between the carbons, and then the outer layer is completely saturated with hydrogens. So this chain, and this chain, all 3 of them, are saturated with hydrogen. So this picture right here that you see in the bottom would be a saturated fat. Okay, if it's unsaturated, okay, if you look at the unsaturated portion, what we have is a double bond, okay, but notice what it says, it's a double bond between the carbons. Okay, so it's a carbon double bonded to a carbon. So if I throw in right here a double bond, my carbon now is going to have 2 of its valence electrons sharing with another carbon. So just to show you, if I draw right here, each carbon typically, like we talked about, can have 4 valence electrons that it can share. Well, if I tell you that this carbon, let me use my eraser, is going to occupy 2 of its bonds, okay, so I'm going to erase this. If it's going to have 2 of its bonds like this, sharing with this carbon, this occupies 1, 2, 3, 4 valence electrons. I cannot put another one right here. You cannot put that because that would be saying that carbon has 5 valence electrons, and that's not the case. So when I do that, and you look at it in structure form, if it's got 2 bonds occupied in a double bond, now that means this one can have one here, and this one can have one here. So there is no hydrogen here and no hydrogen here. So in the chain, when you see this, it creates a kink, is what we call this. Okay, if you think about kinking a hose, it's when you bend it. The kink is when we get a bend in this fatty acid tail due to the presence of that double bond. and it's because of the placement of the electrons. So if I go back a slide, okay, if you look over here, there is no kink because these are all single bonds between the carbon atoms. Okay, but if I throw a double bond in there, I get a kink. Now what does that mean? If you look typically at where they come from, if it's a saturated fat, okay, right here, saturated fat, completely saturated with hydrogens, these are from animal source. This would be like bacon grease, okay, bacon grease. It would be like if you have a steak and you see the fat on the outside of the steak, it's all animal fat, okay, lard is an example. So when they are at room temperature, they become solids. I don't know if you've ever seen bacon grease when it cools down after you've cooked bacon, but it literally solidifies. Okay, too many of this group leads to greater health risk, cardiovascular disease. This is where a lot of people have trouble when you talk about heart attacks and atherosclerosis, hardening of the arteries. That tends to be from eating too many saturated fats in your diet. The unsaturated fats are healthier for you because of that kink. It's easier for us to break that down and metabolize. So this is usually from a plant source, such as our olive oil, canola oil, vegetable oil, and they're liquids at room temperature. So I'm not saying don't ever eat a saturated fat, but you want to limit how many of those that you're eating because it's a little bit harder to break down, and like I said, they're associated with a health risk. Okay, so if you look at this slide, perfect example of saturated versus unsaturated. You can see both of these are triglycerides because the glycerol has 3 fatty acid tails, but this one over here, here's your perfect kink, a double bond between my carbons. I do not have a hydrogen here, I do not have a hydrogen here, so it is not saturated with hydrogens on the outside because of the presence of that double bond. So this would be an unsaturated fat. Here's my saturated, completely saturated with hydrogens on the outside. Okay, I still have, though, just so you know, I still have my ester linkage, my ester linkage, my ester linkage, same thing over here, because I still have my bond between my glycerol and my fatty acids through dehydration synthesis. So that is our covalent bond that you see there. Okay? Makes sense? Well, one more thing I wanted to mention here is if you were to have this kink also in this chain and also in this chain, that's where the term polyunsaturated fat comes from. So if you ever read food labels and you see it talk about polyunsaturated, that's because there's more than one double bond between the carbons that are in the fatty acid tail. Okay, and last thing, this isn't in your slide, but I wanted to mention this because I'm sure you've heard a lot about this. There are things that are called trans fats that are highly publicized right now. People talk all about them. It's basically where you can take one of these unsaturated fats that are from a plant source and you artificially hydrogenate it. It's called hydrogenated fat, so you've probably heard a lot about them, but what they do is they artificially try to stick hydrogens in here in a laboratory. What they've discovered through testing is that trans fats, these partially hydrogenated fats that they manipulate, are leading more and more to cardiovascular disease. So some restaurants have even put them, like, not allowed them to use them in foods at all. Okay, the phospholipid, okay, the next example, so that's enough about the fats and oils. The phospholipid, we will talk a lot about this as we go throughout more units, because when we talk about the cell membrane is known as being a phospholipid bilayer. You probably remember that from Bio 1. But the cell membrane is a bilayer of these phospholipids. It's still a lipid, so we're still going to have carbon, hydrogen, and oxygen, but the name phospho gives it a little bit of a different property here because there is a phosphate functional group stuck onto this. So what that does is it takes your typically hydrophobic lipid and it makes part of it polar. Okay, so this end that has this phosphate functional group has a polar property to it because it likes water. So I'm going to do a smiley face on that part. There's a word that means the same thing as that in the book. You probably read it. It's called amphipathic, and it means having part of it that likes water and part of it is hydrophobic. So we still have our two fatty acid tails. Okay, we have two of them. Here's one here and one here. And we still have a glycerol. The glycerol is in this section. And we also have this phosphate functional group attached to it. So this gives it that partial polar, partial nonpolar ability. So this part is hydrophobic. This part up here is hydrophilic. Well, in terms of the cell membrane, if you put these dudes in two layers of the cell membrane, you probably remember this from Bio 1, they orient themselves so that their heads are facing water inside the cell and facing water outside the cell, but their tails are in this middle section that's hydrophobic. Okay, so that word is also known as antipathic. That means the same thing as that. These are found, notice at the bottom, in all cell membranes. Every cell has a cell membrane, even if it's a prokaryotic organism, because the job of that is to maintain homeostasis. Okay, we're almost done. Hang in there. I wanted to talk about a steroid really quickly. When you think of steroids, I'm sure you guys think of anabolic steroids, which are the injectable kinds that bodybuilders have been accused of taking. That is not this group. These are natural steroids that are found in sex hormones, okay, different types of sex hormones, as well as one that you know well called cholesterol. So cholesterol, as well as your sex hormones, estrogen and testosterone, and there's another one down here called estriadol. There's also one called cortisol. These are all examples of sex hormones that are naturally made in the body, but they are lipid-based hormones. Okay, they're steroid hormones. What they look like, they're very strange. Remember that word diverse? Okay, don't forget this word, diverse. This is lipids. These do not have fatty acid tails. Okay, they lack fatty acid tails. Okay, no FA tails at all. In fact, what you have are 4 rings fused together. Each one of these has 1, 2, 3, 4 rings that are fused together with various functional groups attached to the outside. That gives them different properties and different things that they do, different functions. So here's the common one that you guys are aware of in women. It's called estriadol. It's an estrogen. And then here's the testosterone, which is an androgen. So there's the male and female sex hormones that you guys know so well. So don't forget about those being steroids. And then, of course, put a big star right here. Okay, cholesterol is found in animal cell membranes. Okay, so whoa, that's pretty amazing. We've got phospholipids, and we have phospholipids, and we have these cholesterols. So there are 2 lipids that function in the animal cell membrane. And actually the phospholipid is in all cell membranes, but the cholesterol is in animal cell membranes to help it maintain some structure and fluidity. We'll talk about that when we get to the next chapter, but I just wanted to mention it here. Okay, waxes. This one kind of grosses some people out because of when we talk about, oh yes, ear wax. Woohoo! Get that Q-tip out, guys. Just kidding. So a wax is when you have one fatty acid that is attached to an alcohol. Okay, it's kind of strange, but these are very, very hydrophobic. In your ear, it's a good thing to have some earwax, despite the fact that we do stick some Q-tips in there, but it helps lubricate the auditory canal, which helps those sound waves vibrate and be able to hit against the tympanum or the tympanic membrane, which is your eardrum. So these are also used for lubricants, as coating surfaces. If you've ever had braces before, I'm sure you guys have had some wax that you stick on your braces so your cheeks don't rub raw. That is made of one of these lipids, which is like I said, an alcohol attached to one fatty acid. Okay? Kind of interesting, right? And that concludes lipids.